Hello and welcome. Hey folks, we'll get underway. If you want to grab a slice of pizza and grab a seat, we'll get started. Yeah, okay, got the foghorn. Very good. Well, while you're all sort of starting to make your way to the seats, some of you may have met me, some of you may not have. My name's Peter Hansons. My claim to fame is I'm an AWS serverless hero. I don't have a cape or anything like that, but I just love serverless and enjoy organizing this meetup. It's been a great bunch of fun, sort of learning from all of you, who sort of come to this meetup each month and do some really awesome presentations. Obviously, Simon Waight is first up with his talk on Azure Logic Apps, which is pretty cool, multi-cloud, no-code solution, which I guess is, the serverless nirvana, isn't it? And then we've got Andrew Walker, who has done about 200 serverless consultations or jobs or whatever, and sort of averaged out to be about 5 times faster using serverless. And I think it's really interesting to hear from, I guess, folks that are in the consulting game and how they're gaining a lot of extra velocity from serverless, because sometimes a lot can be said about serverless. Is it a fad, or it ends up costing you more? All of these sort of random sort of discussion points. So I think we've got a really cool meetup tonight. It's super awesome to actually be meeting in person again, finally, after 12 months of live streams and YouTube and stuff. Although, hey, live streamers, we are not neglecting you either. So yeah, without further ado, I'll welcome to the stage Simon Waight. Round of applause for him as well for hosting us tonight. Thank you, Simon. 2 minutes.
All right, so hopefully everyone can hear me online. If you're out there in the audience, please wave if you can hear me. Oh, that's right, I can't see you. Yes, thanks, Rich, for the people in the audience here. Awesome, again, like Peter said, to be back in person. I made the wisecrack earlier about peopleless and serverless. But last year has been a bit like that, and I guess I need to stand over here so the camera can see me rather than wandering about. If I do disappear off picture, it's not because I've given up talking, it's because I have a tendency to wander. My name is Simon Waight. I work for Microsoft here in Sydney. I work in a developer engagement and enablement part of the business. I've been in the serverless community, I guess, 5+ years. I think I gave a talk over at Tankstream Labs when the serverless meetup first kicked off several years ago. So space I love with a passion, and really see the business value in having built services you've probably used without realizing that they've got serverless backends. Today I did want to talk about Azure Logic Apps. So this is kind of an interesting confluence point for serverless, in that it's both serverless and no code or low code. And both of those topics are really quite hot in the market at the moment. And Logic Apps isn't a new concept, but I'm going to talk about something new with Logic Apps tonight. So when we talk about Logic Apps, we really want to start to talk about integration. Now, integration is important for a number of reasons, and there's a whole spectrum of things that we can do with integration that go from application to application integration, all the way through to people and process integration and automation through things like robotic process automation, and those sorts of good things that you can do with Power Platform, automate down on your desktops. The sort of common scenario where we see most integration occur, if you're a professional developer, is probably in that B2B scenario where you're doing data exchange between businesses, or you're writing solutions internally that exchange data between systems inside of your businesses. So all of these scenarios are encompassed by the breadth of offerings that Logic Apps have, and also Power Platform, which shares Power Platform Power Automate, which shares some fairly big similarities with Azure Logic Apps, just in a different execution context inside of Power Platform and Office 365. When we do talk about, press the wrong button. When we do talk about Azure's integration services, there's a few services that we focus in on. As you might imagine, Azure is a cloud platform which has a wide variety of services available. At the moment, I think we've got over 140 different services that you consume. It can be a bit overwhelming as a developer when you first start. But today I want to focus in on our integration services story. So Logic Apps, which obviously I'm going to talk a bit more about. So you can tell I haven't used a presenter tool for a year. It's been used to hitting the enter key on my keyboard at home. So apologies if the screen keeps on going blank. But we're going to talk about Logic Apps today, but a part of our integration services ecosystem inside of Azure includes Azure Event Grid for a reliable backplane for eventing, Azure Service Bus, which is our sort of enterprise large-scale messaging service, some big announcements around Event Hubs, which is associated with Service Bus today at Build, Azure Functions, which is our code-based serverless runtime. If you're working in AWS and you're used to Lambda, that's kind of our Lambda head-to-head. Azure API Management, which is an API integration capability that we have that allows you to take existing or new APIs and publish them securely and control access to them, and then also perform integration between different services. And then Azure Data Factory, which is a part of our sort of data processing estate, probably more associated with services like Azure Synapse these days. On the right-hand side there is an integration services white paper. I'll have the link later in the deck, in the notes at the end. Definitely worth going and having a read of that if you'd like to understand a bit more about the broader integration services capability of Azure. So let's talk about Azure Logic Apps. I'm just going to pause for a second, have a quick drink. Let you drain through what's on that slide, and then we'll talk a bit about it. So Logic Apps, as I said, aren't new. They've been a part of the platform in GA form since 2016. Were first announced all the way back in 2014. Now, for those of you that are part of the Microsoft ecosystem, you probably have heard of a product called BizTalk Server, which is used by a lot of large enterprises to do B2B style integrations, both internally and externally. And Azure Logic Apps is owned by the team or has a team that's made up of people that have been involved in the ongoing development and delivery of BizTalk over a number of years. So that product's been in market since 2000. And when I look at Logic Apps, I see a lot of similarities between some of the designer capabilities that came out of BizTalk Server. So the idea of this integration, low-code, no-code integration's actually been a part of the Microsoft ecosystem for over 20 years. So we're not new in this space, and I think our ability to execute in the Logic App space and continue to innovate, is a real bonus in working with the Azure platform. When you look at Logic Apps, you think, oh, low-code, no-code, great, doesn't really solve a lot of problems for me. But I actually think Logic Apps' secret sauce is the pre-built connector ecosystem that it has. So at last count, there's over 400 pre-built connectors, and that ranges from things as simple as being able to call out to a RESTful API and receive a result, all the way through to sending and receiving Swift messages for banking and cross-country transactions. So we did, internally, our Treasury team worked to build a Logic Apps connector for Swift messaging. So, you can go all the way from the really simple integration scenario all the way through to the really complex integration scenario. And there's most likely a pre-built connector that you can already use in your Logic App. And that's really where I think a lot of the benefit in using something like a Logic App comes over something like a Azure Function or some form of custom integration that you might build yourself outside of Logic Apps, because you're not having to build all that plumbing code to talk to those services and understand the messaging interfaces that you're likely to have to consume or send to. The traditional consumption-based Logic Apps were also completely serverless. So you go into the Azure portal, you say, give me a new Logic App, you build your Logic App out. We'll take a look at one in a minute. And then you don't actually say, I want to put it onto a E3 FizzBin instance size over here with this much compute and this much memory and this much disk. I just literally say, run. And I let the orchestrator that sits behind the scenes for Logic Apps control the execution of that for me. Now, where I pay for running Logic Apps is through the number of executions of triggers and actions inside of a Logic App. I'm not actually paying for the underlying compute. I am paying for it, but indirectly, and I'm paying based on the execution of triggers and actions. The good thing is that that forms part of the broader ecosystem, even with the new changes I'm going to talk about in a minute. Now, the challenge with consumption Logic Apps, they're awesome, they're amazing, but they're very tightly bound to the Azure platform today. So if you wanted to take a Logic App and run it anywhere other than Azure prior to late last year, you had no option really, because you went into the portal or you used Visual Studio to create your Logic App, and then it ran inside of Azure and it used, you know, the services inside of Azure to actually execute and operate. And it also only provided a single sort of out-of-browser capability to author these Logic Apps, which was based off of Visual Studio, which is our Windows-based developer tool. So Windows only, tightly bound to Azure, super powerful, but if you're not in our ecosystem and you're not using our cloud, then great. Why? And that's a limiting factor. So middle of last year, work was going on before that. We announced a preview of what's now known as the standard Logic App or single tenant, which can actually run anywhere. So this engineering work has been made possible through using Azure Functions, which we'll take a look at in a little minute. And actually today was the day we announced general availability of this new execution model, which made my demo fun because I've had to go through and pick up all of the updated tooling bits and discover what changed between the last preview that I picked up and the GA today, of which there was some stuff, but not a huge amount, thankfully. It's decoupled from Azure. So we strengthen this developer story cross-platform, cross-environment by no longer requiring you to stand up your Logic App and run it inside of Azure. And because of that change, we also enabled new capabilities around designer experiences for developers. So there is now in Visual Studio Code designer experience where you can actually create Logic Apps inside of Visual Studio Code. And then that change also enabled us to bring some simpler workflows around continuous integration and deployment of Logic Apps into Azure. So you could do that with the consumption-based Logic Apps previously. It was a bit clunky and it used the Azure Resource Manager to achieve the deployments. As we'll see in the demo, the new standard capabilities are actually much more straightforward, which means we can do things like use a very simple GitHub action to deploy our Logic Apps into multiple environments actually. And with this change, we also enable cross-platform developer experiences. So whether you're on Linux, Mac or Windows, using Visual Studio Code, and I've got an asterisk there, which I'll talk about in a second, you have the ability to author Azure Logic Apps and then deploy them into Azure. The star is there because if you want to do this fully decoupled from Azure, you need to be able to run a storage emulator. At the moment, the Windows storage emulator supports the 3 APIs that are required for Logic Apps authoring to work locally. Just today, we announced Azurite, which is the new cross-platform storage emulator that we've provided to the community. Now provides the additional 3rd API type that it didn't prior to the GA today. That API is still in preview, but the goal is eventually using Visual Studio Code with the Azure Logic Apps standard extension, the Azure Core Tools, .NET, because Azure Functions runtime runs on top of .NET, and Azurite, which is actually installable as an extension in Visual Studio as well. You actually have a fully decoupled development environment from Azure for Azure Logic Apps. Yes, there is a question in the audience here.
Sorry, was that, you said runs on .NET Framework or .NET Core?
So it is .NET Core for the time being. Yeah. So the links that I'll provide later on can take you to the exact requirements to run it. But if you can do Azure Functions development today on your local machine, you'll be able to do Azure Logic Apps standard editing and creation on your local workstation without making any changes. All you need to do is to install the new extension for Visual Studio, and off you go. Internally inside of Logic Apps, we won't look at it tonight. We have the concept of script blocks, which allow you to insert and execute Node.js/JavaScript code blocks. If you do want to do that, you need to have Node.js installed on your local dev workstation as well, but it's not a prerequisite if you're not using those inline code blocks as part of that. So this new standard offering doesn't yet have the full support of every single pre-built connector and trigger that the consumption model does. The team is continuing to work on deepening that, and we'll see how we work with what are known as managed connectors in a demo a little bit later. So I am going to spend the rest of this talk focused on the standard new release, which is GA as of today, and then we'll talk a bit about why we've done this in the broader context of some other announcements from Build as well. So let's do a quick walkthrough of a consumption Logic app. So this is a V1 traditional Logic app. Let me just pull that up for a second here. Yep. Yep. Everyone loves Clippy. Let me just open a link here for you for a second. Resource not found. Awesome. Okay. Thanks for that. So we'll come in here. So this is a pre-built Logic app. So rather than click through and show you how to build one from scratch, I'm going to quickly walk you through this one. That's not what I wanted. So that's actually a custom Logic app connector that I built to talk to the meetup.com API. It's really simple to build your own. Effectively, they're a open API definition over the top of whatever it is you want to consume, and then that provides an interface that Logic Apps can use. So I'm a member of so many meetups that I got tired of trying to keep up with all of the announcements. At work, I use Teams a lot, so I figured, well, I'll just post messages about when new meetups are announced into Teams, and I can do that using the Meetup public API. I didn't want to write a lot of code to do that because, frankly, I didn't think it was necessary, so I thought I'll use Logic Apps for it. So if I open this Logic app in the designer, so this is the one that's tightly bound to Azure. I could actually convert this now probably into a standard Logic app and run it anywhere that I wanted. But for the purpose of this demo, just to give you a quick walkthrough. So the trigger for this particular Logic app is called a recurrence. So it happens once a week on Tuesday, Thursday, and Sunday at 4 a.m. And what it does is it'll actually kick off this workflow and run it at that time. I then initialize some variables. So very simple, here's the variable name, here's the type, and I can set an initial value if I want. I get this nice designer layout here. I then go off and I talk to Teams because I want to have a look up. I want to look up the channel inside of Teams that I want to publish to. So I go away and I say, hey, Teams, for this team, give me all the channels. And my channels match the meetup cities that I'm interested in. I then have my meetups that I'm interested in listed in table storage inside of Azure Storage, which is a really simple key value JSON. Sorry, it's a NoSQL JSON store where I can have any number of key value pairs hosted in there. It goes away and reads that list out. And then what I do is I iterate over each of those entities. I convert it into a object. So I convert the entity I read out of storage into an object. So I've got properties that I can use and reference in my Logic app. I've got a slight delay in here because the Meetup API will throttle me if I make too many calls to it. So I've set an artificial delay into here. I then call my custom connector. Row key is just the unique key of the Meetup that I'm interested in. So I pass that in as the Meetup group because Meetup is meetup.com/group name. And then I say in the response, I actually want to get back next_event as an additional field that's not returned as a standard field in the responses from Meetup. Then I check what the result is. So I check to see if the event ID is not null. and that the event ID isn't equal to the last event ID that I got, so I'm not continually repeating the same events. If that fails, I don't do anything. Just let that branch go and do nothing for me. If it succeeds, that means I have a new meetup. Let's just zoom out a bit. It's been chopped off. I then go and get the full event details, because that initial call just gives me when the next event is and what the ID is. I then get the full event, extract the name of the team from the meetup announcement, because I know what city it's in. I find the right channel that I want to post to. And then what I do is I'm using a thing called adaptive cards, which is an open standard, which creates a nice looking layout template to post into a Teams message. I build that adaptive card using a bunch of JSON, and I have these really cool placeholder functions that I can use in Logic Apps to do things like string concatenation, replacement, looking up items in collections and all those sorts of things. So I build this JSON object up, which is an adaptive card, and then I finally take that adaptive card and I post it into the channel. So here's the channel ID, here's the team, and then the adaptive card is the content I'm going to post. And then I update the entity in storage table. So that's great, works a treat. You will have noticed that it's got some failures in here. So one of the beauties of Azure Logic Apps is that you get a really nice graphical experience when it comes to looking at runs. You can also do alerting and monitoring over the top of this. So when it fails, you get an alert saying, hey, something went wrong. But I can see here that for all 65 executions, everything was green, nothing failed. So there's next failed's got nothing in it. But I could literally step through and have a look at the raw input and output for each step, debug it that way if I wanted to. So that's the traditional one, super powerful, but it's bound to Azure. And if you want to design it, you either do it in the browser like I am here, or you use Visual Studio. And frankly, the browser was probably the more efficient way to design these things. If you did want to do CI/CD with these things, you can export the template and parameterize a lot of the content in the template. So if we have a look just quickly in the designer, you'll see there's some options across the top here, which is code view, parameters, and templates. Code view, Logic Apps is a DSL over the top of a JSON object. So if you look at the code view, it's just literally a series of JSON statements, and it works backwards. So the start of the Logic App is at the very bottom, and then you build the Logic App all the way through. So you can manually manipulate that JSON if you're brave enough. I wouldn't recommend it. The Visual Studio Code editor experience up until we announced the new feature was literally editing the JSON only with some IntelliSense support, which frankly isn't much of a developer experience. It's more like adding bugs to a JSON file and then wishing for the best. So that's no longer the case. So that's the traditional, what we're now calling consumption Logic Apps. They're not going anywhere. They exist. We see a lot of use with things like using them as eventing endpoints for things like Azure Sentinel, so our security product. So there is a massive community of pre-built community Logic Apps which you can attach to Sentinel to do certain things. Maybe sending a message into ServiceNow, calling Twilio or PagerDuty to send pages to your security team. And we use them in quite a few other places inside of the Azure platform as like an extension point for ops folks to be able to go in and easily add extensions into Azure for them to use themselves. I've got 9 minutes left. Let's see how I can go with 9 minutes. All right, so that's kind of the traditional model. Let me just pull up. Where are we? So, as I said, that model works well, isn't going anywhere, but it has some discrete limitations in terms of where developers want to be. It doesn't appeal very much to people who aren't working with our platform. Last year, the team made a decision to look at re-architecting the underlying runtime, and basically now Azure Logic Apps runs as an extension on top of the Azure Functions runtime. Now, if you've worked with Azure Functions previously, you'll know they're already cross-platform. You can develop them on any platform that you're working on today. And it makes sense that if you want to start to build a cross-platform Logic Apps capability as well, why reinvent the wheel and try and recreate the underlying orchestrator technology that we use in Azure? Use something you already have. So we already have a strong containerization story for Azure Functions. We already have a really strong PaaS hosting story for Azure Functions, and we have a strong cross-cloud story for Azure Functions because you can containerize it and run it on Kubernetes if you really want to. The good thing with this change is that we can now do the Visual Studio Code editor experience because we can use the existing Functions runtime tooling that we have for Visual Studio Code as the baseline that we can use ourselves. Because of the changes, we've also got a much cleaner CI/CD story, which we'll take a look at in a minute. And we have a new method for invoking Logic Apps. So traditionally, Logic Apps were stateful and weren't well designed for doing things like being attached to an event stream for a highly utilized IoT service that might receive millions of messages a day, because the cost of executing a Logic App, even just to check to see if the message was worth processing, was probably not worth it, right? It was the wrong method to use it for. With these changes, we now have the idea of a stateless workflow. A stateless workflow is much better suited to that use case where it might be a very simple request response, responding to an event on, say, an event stream, where you maybe want to do something very simple like take an event, do a very simple transformation to it, and then write it to another event stream. With this new stateless execution model that's available only in the new standard offering, you now have the ability to use Logic Apps in that scenario and control the cost much more than you could with the traditional method. Because we're using Azure Functions runtime, we also pick up a lot of the underlying goodness that we get out of Azure App Service, which is where Functions runs inside of Azure today. So we get VNet integration, so virtual networking integration, private networking endpoints, and the ability to hook application insights for our monitoring and application performance management. And we've added the ability to use the new Azure Communications Service as well. So that's our text, voice, and chat or service that we've stood up in the US. Isn't available yet here fully in Australia, but you can imagine the sorts of automation scenarios that you can enable using Azure Logic Apps with, say, a voicemail system, for instance. You know, new message received. Okay, well, we'll fire up a Logic App off the back of that. Maybe take the audio file out of the voicemail box, run it through text to speech inside of Azure Cognitive Services, or speech to text, and then send the text in an email to somebody in the organization. You could absolutely do that with Azure Logic Apps and Azure Cognitive Services today. All right, demo, because people are tired of hearing me talk and show slides. So this one doesn't need the Azure portal. So this is in Visual Studio Code. I'm just going to zoom in a bit. I've already done all the kind of the baseline heavy lifting on this because you don't need to see me doing a lot of typing. If you've used the Azure Functions tooling before, some of this will look familiar to you. Host.json, local.settings.json. So basically the host is the Azure Functions runtime hosting. But what we do get is we get this new concept of the workflow design time. So that's actually a very specific piece of the tooling that uses an Azure Functions execution to allow you to access the designer experience for Logic Apps. So what do I mean by that? So let me just zoom out a bit so that we can see this. And if I come over here, I've already built a Logic App, a new one called Describe Image in an Email. And what I can do is I can do a few things here. So I'm going to open in the designer. So the designer experience is actually running on the Azure Functions runtime behind the scenes. So it fires up a Functions runtime behind the scenes and then serves this experience off the top of it. But based on what you saw inside of the Azure portal, this looks very similar. There's not a lot of difference, but I'm completely disconnected here. I'm running inside of Visual Studio Code down on my machine. I could be doing this on Windows, Linux, or Mac, and I have that whole process available to me here. So this is a very simple Logic App that's just receiving a HTTP request and at the very end returning a response. And then in the middle, what it's doing is I feed it a bit of JSON, which has a public image URL. And then I'm using Azure Cognitive Services computer vision to explain or describe what that image contains simply by passing the URL to Cognitive Services and saying, hey, tell me what this is. And then taking the first description that I get back from Cognitive Services and sending it as an email. Now, I'm using the Office 365 Outlook email connector here, but I could use the Gmail connector. I could use the Outlook/Hotmail connector to do that as well. I would have loved to have used one of those other connectors, but our corporate policy blocks me from being able to use some of those for data leakage protection reasons. So I send myself an email internally in this demo, which is great. What else do we want to see here? So if I start debugging this, so I'm just going to hit F5 in here, and then this will fire up the functions runtime. Apologies, you probably can't see that, but trust me, the Azure Functions runtime is up and running. Zoom in a bit here. So it'll take a little while to start up just because my machine's doing a lot. So you'll see down here it says building in the bottom right-hand corner. It'll go orange once it's ready to debug. Now, the debugging experience in Logic Apps inside of Visual Studio Code at the moment is pretty rudimentary. So I can't come into these steps and set a breakpoint. But what I can actually do is I can open the JSON behind the scenes. So let's find one here, set image description from first caption. I'll set a breakpoint here. So this is basically mapping to this step inside of the Logic app here. That's all right, it's just taking too long to fire up. It'll start running eventually. Come on, you can do it, computer. So this is using .NET Core. You can see here it's got .NET.exe behind the scenes. It's just running to do that because the sort of wrapper Azure Functions project that's used to execute the Logic app is a .NET Core based wrapper. Yes, it's a question. The Azure Functions ASCII art? No, not here. So let's just try again, see if it's going to behave itself this time. One of the changes I took out today was you can set the timeout for the debugger to attach to the project, which you need to do sometimes with some of these projects because they take a little while to get to execution, and the debugger just goes, I didn't get a response in enough time, I'm just going to stop. Hopefully this time it'll do what it needs to do. So what's the setup for VS Code and? So I'll talk a little bit about that in a minute. In fact, while that's trying to figure out whether it's going to execute or not. So I talked a bit about, leave that sitting in behind the scenes. Let's just come back over here. What do we want to do here? So Logic Apps have this idea of built-in and managed API connectors. So built-in is run anywhere, baked into the Logic Apps runtime, don't need anything to do with Azure to get them to work. Our managed API connections, so the things like calling cognitive services, calling Office 365 Outlook, are what are known as managed connectors, and they require you to have some form of authorization externally. And what we're doing behind the scenes for you is we actually create a proxy inside of Azure. So your Logic app talks to what's known as a connection object inside of Azure, and that connection then talks to the service on behalf of your Logic app. If you want to use the Azure managed API connectors, you do absolutely need to have an Azure connection because those connectors run in the context of a resource group inside of Azure. So for this particular demo, yes, I need to have an Azure subscription. If I want to use the built-in connectors, then I won't eventually need that. Today, I still need a little bit of glue to hook me back into Azure, but the long-term goal is that you should be able to stand up at least the built-in connectors without having to bolt it into an Azure subscription. So the example here, and I'm sorry, I'm walking out of frame. So built-in, managed, and then the Office 365 connectors off the bottom. So if you want to use any managed connectors, and realistically, if you're doing any form of heavy-duty integration, you'll be using managed connectors. You're not going to be using built-in connectors to do a whole lot of stuff. Okay, so it failed to connect, but that's fine. We can see here that the runtime is running. It's given me a URL where I can go and invoke this from. Now, in order to be able to call Logic Apps, I need to provide a SAS key, which is basically a time-limited authorization key. In the Azure portal, that's all kind of managed for you behind the scenes. If you want to find out how to do that with these new workflows inside of VS Code, you basically right-click on the Logic app and you choose Overview. And hopefully this will work even though the debugger is unattached. You'll see here I now have a callback URL. If you are doing things like using the webhook connector, you need to use like a service like ngrok to be able to publish your machine as a publicly reachable endpoint for the webhook to call back to. We're not doing that here. We just got to post a HTTP REST endpoint we're going to post to. So I need to provide that full URL in order to be able to invoke the Logic app properly. Otherwise, I'll get an unauthorized response. And then I also get this neat history, which looks very much like what you got in the Azure portal before, including success and failure. And I can now open that run. Let's just see if we can drop this down a bit. And this is all inside Visual Studio Code, so I'm not actually connected to Azure to do this. And this is using the storage emulator locally to manage that context for me. And they get the same experience that I had with that consumption-based model, but inside the Azure portal. I now get that locally here with a bit of extra special sauce, which I didn't get before, like, well, this didn't run, and I can find out why it didn't run, whereas before it was kind of I assumed that because all the green ticks went a certain way through the workflow, that was the path that it took. And then what happened? So let's find out what happened. Let's execute this. So I'm actually using, this is a cool extension that I just read about this week, actually. It's called Thunder Client. So it's like a REST tool that you can have right inside of Visual Studio Code. If you've been using Postman for a while, you'd be fairly familiar for the way this works. So I'm going to invoke the endpoint that's running locally. I pass it in a piece of JSON, which is basically just got a file to process and then a URL. So if I send that locally, we can see the debugger flicking through at the bottom here. We can see the execution of that workflow. So that's very familiar if you've done Azure Functions before. And then I've made it return a HTTP status code if it worked okay, and then a bit of JSON telling me what it was. So let's go and have a look at what that image actually is. Almost done. I know I'm probably over time, so thank you for your patience. So I was a bit disappointed that the Azure AI didn't have the capability to recognize them as kangaroos, but it got the fact that they're animals, which I guess is good, and that they are standing on grass. So that's pretty cool. And then just to show you that there was real stuff happening here. So I'm just going to refresh my inbox here. And then this is the email that I sent myself using the connector. So I actually sent it to an internal distribution list that I'm part of, which is called Aussie Azure Devs. But it's just the same text that you saw in the HTTP response. Now, I love that simplicity, being able to use that code and that tooling like that. I know as a developer, sometimes you look at low code, no code and go, it's a kid's toy. It's actually really powerful for doing integration and like B2B integration where you want to do transformation as well. So you can do things like liquid templates, XSLT, all those sorts of fun and interesting topics can be embedded inside of a Logic app as well. So it's not a rinky-dink kid's toy that looks nice. It's actually got some real-world scenarios backed by it as well. Now, I will quickly talk you through the CI/CD capabilities for this and how they've changed. So let me just pull up my GitHub repository here. So this was based off of the preview, which is now no longer a preview. It's the Logic app that I just ran. It's checked in as it is. So you can see here's our describing image email and our workflow.json file. But what I've got now is I actually have a GitHub Actions workflow in here that actually deploys it into Azure for me. So in order to be able to do this, what I do is I go into the Azure portal and I say, create a new Azure Logic App standard It's basically a hosting plan for me. It has no workflows deployed into it. It's literally just a bucket into which I can deploy multiple workflows. Again, if that sounds very familiar to how you do Azure Functions, that's because it's very familiar to you from that world. And that's another difference, right? Is when you created a Logic App consumption, the very first version I talked about, there was like, I create a Logic App and off I go, that's it. There's like one Logic App, one execution. With this new model, I can now put multiple workflows into a single Logic App. You probably won't have too many scenarios where you might do that because you don't want to hit up against resource exhaustion because you've got multiple heavy-duty workflows running in the same context. But it does give you the ability to take multiple smaller workflows and deploy them into a single Azure Logic App instance inside of Azure. So let's just take a quick look at what this Logic App is, or sorry, what this GitHub action is doing. So it's using the Azure PowerShell modules behind the scene to do a lot of the heavy lifting for us. Azure PowerShell is cross-platform these days. With PowerShell Core, you can now run it on Linux, Mac, and Windows. We log into the Azure subscription. Because of those managed connectors already live inside of Azure. When we create them, we have to say, I want to create them in a resource group, and then they live up in Azure. What we're doing here is we say, go into this resource group and discover everything that's of a type connection, and create a connections.json file for me, which defines the connections that will be deployed and connected to my workflow when I deploy it into Azure. So rather than hard coding them, I can discover those as part of this workflow. I then also call into Azure App Service, which is kind of the underlying mechanic that we use to host these in Azure, and say, get us the published profile, which is the mechanism we'll use to actually deploy the workflow into Azure. So again, we're not hard coding that as a secret in GitHub Actions. Create a project folder, so just create something locally that we can do some work in. Move the files that I care about, so it's effectively workflow.json and a couple of other configuration files like connections.json. Zip them up into a file for me, publish that zip file up into Azure, and because it's using the Azure Functions runtime, Azure Functions runtime knows how to manage zip deploy packages. So I use the zip deploy packages capability inside of Azure Functions to manage the deployment for me. And then what happens once that is done is we end up, where are we? So here's my new kind of container to contain all of the Logic Apps. Don't go in too fast. So that's my Logic App. You can see it's called Logic App Standard. I now have this new concept of multiple workflows in here, so I can see the connections that are aligned to this workflow. So it'll take a little while to refresh and list those. There we are. So there's my computer vision and Office 365, and it'll say so that's what I am using locally on my machine when I'm doing the development work with these managed connections. And then I can see my workflow, which has been deployed. So you'll see this is called describe an image in an email. And then if I really wanted to, I could go in and manage this in the portal if I wanted to. That wouldn't be the right way to do it because I've got CI/CD attached to it. I suspect where we'll go with this eventually is that if you're deploying using CI/CD, we'll block you being able to edit it in the portal, which is what we do with Azure Functions. So if you're using CI/CD, you can't make changes in the portal so that you can't futz with things that'll then get overwritten later. And we actually get the same experience in here. We can see the full debug capability in here. Come on, you can do it. And then I've got one last thing to say and then I'm done. All right. So just to show you that that's going to work. So let's run the same against the one that's deployed into Azure. Okay, a large body of water with a city in the background. And then let's have a look at what the images that we asked it to look at. So I'm a bit disappointed it didn't manage to get Manhattan out of that, but I guess that's probably not enough definition for anything to figure out that it's Manhattan. Could be a lot of different city skylines, that one. I will have gotten an email for that. Cool. All right. So that's kind of that piece there. So why do we do this? Now, if you watch Build today, you probably saw one of our key announcements. is around this idea of app services, multi-cloud enabled app services, which is effectively, we've taken web apps, Logic Apps, Azure Functions, API management, and Event Grid, and we've packaged them up in such a way that they can be deployed to any CNCF capable Kubernetes cluster. The only proviso that we have is that the cluster's got to be Arc enabled. So that Azure Arc is our cross-platform, cross-cloud management tooling for a range of different services, including Kubernetes clusters. And what we do is we now give you the ability to say, okay, I could build with Azure PaaS. I could build all of these services using the native capabilities in Azure as a service. But then also what I want to do is I want to take all of those as a service underlying infrastructure and I want to deploy it into AWS on EKS or GCP on GKE, or I want to run it on-prem as part of my own Kubernetes cluster. And I can do that by saying, okay, I now want to enable this service tier to be available on my cluster. And to answer your question, Rich, that's where Jeff US came from today during build. So Jeff deployed the services down onto his. So Jeff Holland's one of the main folks behind the scenes was Azure Functions, now is working more broadly on some of the work that I'm talking about here. But he deployed the services down onto his laptop and basically was able to execute those workloads locally. So the number one thing we keep hearing from people is we love Azure PaaS. It's a really great tool for developers to be productive and develop modern solutions, but I don't have a really good story if I want to take that workload and run it somewhere else. Now you have that story. Okay, and the benefit you get with Azure Arc is you can do things like apply Azure policy to your Kubernetes cluster regardless of wherever it is, and you can make sure that things like the app services, containers that are running the underlying infrastructure are kept up to date and in alignment with what's running inside of Azure, so you can maintain the state and make sure that your environments aren't drifting from what we run inside of Azure. And then all the other goodness around it, so things like CI/CD, and a consistent management experience regardless of where you deploy it to. So that's kind of the underlying reason of why we've done a lot of the engineering work to lift Logic Apps out of their traditional execution model and bring them on top of Azure Functions. I will put this up quickly if you want to take a snapshot of that. I will put the slides up later somewhere and then post a link to Pete to share. But if you want to grab any of those links, that QR code will take you to the documentation and demos from today. I think I'm probably over time. I'm not going anywhere, so if you want to grab me for questions afterwards, or while we do a tech changeover, if you want to grab me for questions, we'll do that now if that's okay while Andrew comes up.
Yeah, we can do a couple of questions if that's
just
okay.
Short ones, otherwise grab me later.
Yeah, I'll just give you like this so that online people can hear you.
Yep, sure.
Do you want to, sorry, Andrew, do you want to swap the laptops over?
Yeah, so for customers who are currently using app service environments, are they able to leverage that to use with Logic Apps standard?
If they're using app service environments, can they use? I'd need to have a look at that. So you're talking specifically about ISEs? ASEs. So if you're using ASEs today, so ASE is more aimed towards app services than it is towards Logic Apps. So the Logic App equivalent of an ASE today is an integration service environment or an ISE. Let me just stop sharing this. I'm just going to stop my screen and then it comes back to me and then I can disconnect there. I'll get out of the way so Andrew can get his set up. So I don't know off the top of my head the answer to that. So the question is, if I wanted to use the Arc-enabled capabilities, could I deploy the Logic App into an ASE?
So, like for example, how do you use ASE to deploy web apps and Azure Functions as well?
Yep.
Because Azure Logic Apps standard runs on the same function runtime, would we be able to use an app service?
I guess you could. I haven't specifically explored that scenario, but because it runs on the Azure Functions runtime and it can be containerized, nothing would stop you from being able to deploy it into that space. All I would say is that the Arc-enabled stuff so far is only focused on Linux workloads. So if you are using Windows-based web apps today, then you would probably have to have a separate ASE running Linux to be able to support that. Okay, any other questions? And then I'll hop out of the way. Otherwise, grab me afterwards.
I was just going to say, really, Thanks, heaps. That looks fascinating. I guess is the target there, Simon, just kind of like it seems like you're trying to bring serverless to more sort of regular business folks and stuff like that. I mean, in my day-to-day job, sort of doing a bit of data engineering and stuff like that, I often speak with data analysts or marketing folks that have just they'd find it impossible to launch a function as a service on a cloud platform. But this almost feels like it's business folk ready. So
I'd say it's partly that, but it's also, like I said, meeting the demand where it is, right? So, the common thing is we don't want to build on your PaaS platform because we don't have a fallback, we don't have a DR story for this, or we have to build in certain ways so that we can use your platform. And frankly, it's just all too hard. With this, it's no longer an issue. That's really what it's about. So if you're a business person, you want to use serverless, you probably go to Power Platform from our standpoint and use Power Automate flows to achieve that. But look, I've taken up a lot of time. Over to you, Andrew. I'm about
Fantastic. Have I pressed all the right buttons?
I think so, yeah. We'll get
Cool.
it sorted out now and take it away, Andrew.
Fantastic. So let's talk money. I love tech. When I first saw platform as a service 10 years ago, I was blown away. I just couldn't believe that the art of the possible, even back then, and things have moved a long way in a decade. When you're trying to get platform as a service or serverless technologies off the ground in a project, you've usually got to talk money. If you can't convince someone that it makes financial sense to run a project on serverless, then I've had a lot of failures. Very excited about the technology, but couldn't get a project off the ground. Just want to go through some of the experiences that I've had successfully selling the idea of a serverless project. And what it really comes down to is the fact that a serverless project costs at least half less. So if you've got a $2 million project and you're able to run that on pure serverless, and I know mostly pure serverless, it's going to come in roughly half the budget or less. The most dramatic that I've seen is 90% less budget. And I'll walk through some examples of some of the things that have been that dramatic. But the other one is a massive time difference. So obviously if a project is roughly half the size, you're going to have roughly half the time, right? So it's just less resource. But there are some other time advantages that go well beyond just the delivery phase of a project, actually the pre-delivery phase, when you try to get the project off the ground, get it architected, get the solution designed, get the money before you start the project. And there's some massive savings there in terms of time as well. So I guess the one message that I'd like to leave today with is that the easiest way to sell serverless is to not mention it, is just to quote it up on the basis of serverless. The less you mention, the less likely it's going to cause a barrier to getting stuff delivered. And why is it that it costs less? Like, why does it take less time? I think we've all been here. I remember setting up data centers 20 years ago, and they looked like that. That's a bit of technology, and it's easy to replace that with the easy PaaS thing that we've all seen before. Right? That's the same solution. The difference is, in here, we've spent at least 150 meetings. At least, like that is really, really conservative. A lot of those meetings happen before you start the project. Right? So you've got, probably 7 to 10 different forms of architecture, network architecture, You've got, different sorts of technology security around different domains. All of that stuff takes time. And until you've done that, you can't start building and deploying code, not even really seriously in dev. You can do it on your laptop, but you can't do it in a real dev. You can't do it in test. You can't do it in prod. So there are some opportunities if you can use serverless and if you can get the business case across the line. I'm working with a client at the moment who spends $40 million a year on just data projects. So this is building systems of insight, a little bit of AI around the back of that. They generally present that data up as an API. So, data processing of some sort gets pushed into an API and then consumed by operational systems. So 40 million bucks a year, every year they spend on projects. So most of that money goes on humans, right? It's not the infrastructure that costs the money, it's the humans thinking about the infrastructure that costs the money. So when you move to something like that, you have the ability to go live within the first week or two of the project because you're not spending any time whatsoever talking about infrastructure or getting infrastructure ready for developers or for testers. The first time I did that was I was working on a project for News Corp. It took us a year and a half to get the funding for that, $3.9 million. This was for a self-service platform for its customers. Budgeted for $3.9 million. We got permission to do that on the PaaS of the day, which happened to be App Engine. That project came in at $1.9 million. So there's a real budget set aside to build a real solution. Our first release was in less than 1 month, and we just carried on doing continuous releases week on week on week until we finished about a year later. The very next example was a ministerial briefing system for Victorian Parliament. So this is a system where they effectively managed, coordinated a whole bunch of humans to get briefing papers to ministers for Parliament. It's a pretty simple process, actually. They were doing it in emails and stuff. They'd failed twice. So they'd failed for 3 years running. Business case, get it funded, start the project, fail. Business case, get the funding, start the project, failed for a second time. First one was delivered on SharePoint from memory, and the second one, I can't remember the technology. We came in, and 9 weeks later it was done for 132K. And the only difference was that we weren't touching infrastructure. We still had to write code, we still had to build a solution, we still had to talk to users, we still had to test. But it gave us a lot of options in terms of how we ran that project that were very, very, very different from the way that things normally happen. My standard, so I'm a career project manager, my standard project before that looked like 12 people, like a team of devs with a team leader, business analyst, technical architect, solution designer, project manager, a few other people around the edges, graphic designers. What we found doing this stuff over and over and over again for a whole bunch of different clients and a whole bunch of different industries was that you can reliably get these teams down to 3 people. And when you get teams down to 3 people, a whole bunch of magic starts happening, like you don't have as much communication overlap between those people. You can all of a sudden get most of those 3 people, if not all of them, to most of the important discussions that you're having with users. You don't have to divide and conquer, you don't have to split. So the traditional hierarchical split of functions in those teams went out the window, and we were able to deliver at a speed that is, it makes Scrum, it makes retrospectives, it makes sprint planning, t-shirts, t-shirt sizes, horribly, horribly wasteful. These are some real examples that I've taken from a while ago. You can see on those at the release date. So typically these would have sort of 5 to 7 features per release. And you can see that those releases aren't a huge distance apart, right? They're 1 day, 2 days, 3 days, a weekend. I have around about 2,500 of those emails from a team of 30 people. And all of that is possible because you just delete a huge, huge, huge amount of work from the project. It enables you to reduce the team size. And when you reduce the team size, you start to get a style of work and fluidity that isn't possible if you're doing 2-week sprints, 1-week sprints, 3-week sprints, 1-month sprints. What a project then looks like. So if you look at the dotted lines on here, what I'm trying to depict is the pre-project phase, right? So you start talking to a user and they say, look, we've got a problem. It's taking us 13 weeks on average to offer a law student a place. From that conversation through to when you start a project is normally, in my experience, between 9 and 18 months. Right? You've got to go through a whole bunch of high-level business case. You've got to write the business case. You've got to socialize the business case. You've got to come up with a solution, choose a technology. Quite often, we'll try and buy a technology to solve the problem. In a lot of cases, you could have built it and deployed it very quickly for a 1/10 of the price. That whole selection process, that whole analysis process, the whole funding process takes generally a lot more time than it does to actually just deliver the solution. I'm sure you've all been involved in that as architects and software engineers. You've been involved in that phase of the project as much as I have. The other difference is typically, even if you're doing Scrum, even if you're doing Agile, even if you're doing XP, you can do Agile, you can deploy into test during the project. But in most projects of, say, $2 million, $4 million, which is sort of, for me, the median, you're still going live at the end of that process. You're not going live at the beginning of the project. So you get this whole, oh, we're doing Agile, we're just not deploying into production, which for me just isn't Agile. I mean, to me, the whole idea of Agile was to deploy into production. Release early, release often wasn't referring to test, right? I'm pretty sure. So what that looks like in a project that you're running on serverless technology is you start having a conversation with business people about what the problem is. The commitment required to build a solution around that is so small that you can have a conversation with someone who has a BAU budget, and they can actually set BAU budget aside to build a pilot for that solution. So you might not deploy that to 1,500 people in your call center, but you can deploy that to 1 or 5 people in your call center. You can deploy it into production, because that app doesn't have to be the size that it is eventually going to be. That app can just be the core, and you can have procedural workarounds, human workarounds. But what you can demonstrate by running a pilot on serverless technologies is that you are absolutely going to nail the business benefits of building a solution. So in the example I used before with the law students, we ran a pilot in around about 2.5 weeks with 1 person out of 8 admin staff, and we were able to pull forward the amount of time it took them to process just their applications by, on average, down to 2 weeks. So from 13 weeks down to 2 weeks. Just building a lightweight solution, light integration to back-end systems. We then followed that up with a proper project, which cost in the order of 500K, when the previous budgets for building a solution were somewhere in the order of 4 million. So I guess the secondary message here is not only are serverless projects cheaper and faster, but they also allow you to do things and solve problems in a different way. You don't have to commit to architecture. You don't have to have all that big design up front from an infrastructure perspective. You don't have to go out and buy products the whole time. You can follow up and buy a product later. You could run the pilot by building a lightweight solution yourself. So even though the delivery phase there is shorter, we're still delivering the first couple of production releases at the beginning of that process. So we spend the money during the project. We release features to real users during the project rather than just at the end. Tertiary benefit, developers love solving human problems. When you give them an architecture at the beginning of the project and tell them to build the solution that someone else came up with, it's not that much fun. When you give developers access directly to users and allow them to run a pilot, it's extremely satisfying. Retention goes to the roof, turnover goes down. And it has a pretty fundamental impact on what you buy and what you build. If you know that you can build a solution, if you look at something and go, right, this thing's going to be a pretty lightweight user experience around some integrations into some back-end systems, which frankly is, you know, a lot of digital solutions, a lot of the budget that we're spending is that type of assembly of a user experience around platforms. If this looks like a project that's going to be in that space, you just delete that whole consideration of 10, 15 different technologies. You just go, right, there's only 3 things I can use to deliver that. Sorry, it's probably going to make someone epileptic, but you could probably add 7 icons to that PaaS stack and deliver pretty much every one of the digital projects that I've seen over the last 10 years. You need some queues, you need some, you know, document stores, you need some SQL, you need some big data, you need some web. So, you know, app services, front, back end, bit of blob storage. You assemble those together, always knowing that if you've got blob storage, it's going in one place. You don't have to think about it. You've pre-architected the solution. You don't need to architect it. So my mantra for the last 8-ish years has been buy platforms, build solutions. Don't even consider buying a solution until you've built a pilot. Because even if you throw away the code for the pilot, the analysis and design and learning that you've had from deploying a real solution to some real humans is going to save you money when you buy a product. I'm sure you've all seen, we buy a product and it doesn't work the way we want it to, so we customize it a lot. I've seen so many poor Salesforce implementations where people just haven't thought through how to use the product to its best advantage. And if you pilot stuff with small groups of humans, you can overcome that. So buy platforms and build solutions. The other thing that I find really interesting in any large enterprise that I've been in the last 20 years, really, is that CIOs will give the job of assessing serverless, they'll give that job to the head of infrastructure. And that's good. So it's a double-edged sword as a problem, right? The first is obvious, which is that it's not really in that person's interests to push serverless solutions, right? They're head of infrastructure, and then I think they were having a conversation earlier on about wanting to sweat the asset of infrastructure. It's a very common paradigm. But actually, it's a more subtle problem in that an infrastructure person there's no reason for that person to educate themselves on what platform technologies are. And the benefits for platforms, so the benefits for serverless, aren't won by the infrastructure people. And that's the crucial thing. The people who benefit from serverless technologies are developers. And CIOs don't give developers the job of choosing the right technology to deploy on. They give that job to the infrastructure people. So there's this problem that you've got to try and work around in most organizations where you've sort of got to move up 1 or 2 levels to put a pretty large business case in front of a CIO and really educate, help people understand the difference between those technologies, because they think of serverless just as a different type of infrastructure, which of course it is, right? But it's a fundamentally different category of infrastructure. I think of it not so much as serverless, I think about it more as fully automated. So when I'm trying to explain to a business person what serverless is, it's just, we haven't had to automate our infrastructure ourselves. We've got people from Microsoft, Amazon, and Google who have done that for us. They've had to do it internally for their own reasons. And we're now taking advantage of that automation. And the real advantage isn't in operating costs, though actually my experience is that we can run infrastructure at a much, much lower cost on platform technologies. But it's not just that, it's the cost of the projects themselves. And if you think about a typical, say, $4 million project, your operating costs for that are going to be 10% of the project cost. You're not going to be looking at those as being a significant cost for the next 5-10 years. The real cost of engineering solutions is the engineering phase. And actually, in terms of time, the real cost of an engineering project is the wasted time, the opportunity cost of starting that project late. So if I've got a $10 million project, I'm generally these days expected to be able to show a business operating cost reduction. So, removing people from my customer onboarding process, or reducing the size of my call center, or getting twice as much volume through my call center. If I spend $10 million on a project, I'm probably expected to be able to save somewhere between $5 and $10 million a year out of my business. So if you think of that, for every year that it takes you to start the project, you've wasted $10 or $5 million of business benefit, as well as the cost of the project itself. So it is possible to put together business cases, really simple business cases actually, that get this point across to people. And what I've seen is that people who approach CFOs first, and then through the CFO work with the CIO, have managed to make a pretty big difference in terms of how they adopt serverless. And finally, I will leave you with my definition of serverless, because there are a lot of managed services. From an operating point of view, I think that a good, strong managed service where you define the size of the cluster, you do some sort of drag and droppy type stuff. From an operational perspective, I think they're great. What we've found, though, is that when you're running projects on that type of technology, you don't typically get the same developer productivity benefit that you would get on a genuine PaaS service like Blobstore or like App Service. Did I get that right? Is it called App Service?
Azure. Well,
yeah. Service, yeah, good. So my definition is if it takes you less than 1 hour to set up in production, so if you can deploy to production 1 hour after you start the project, for me, that's serverless. And that comes down to tooling as much as it does around the actual service itself. That's it. That's it from me. Questions?
I just get this microphone thing working just so for the benefit of our future selves. Maybe you want to watch it. Matt, did you have something?
So it sounded like a lot of the projects you worked on were new projects.
All.
Huh? All?
All. Yeah.
Okay. Well, my question was going to be, how do you tackle brownfields? I mean, how do you assess where to start and how to estimate taking down, large legacy pieces of infrastructure?
It's a totally different thing. Like for me, I've enjoyed building new stuff. That's my thing. I like building new stuff. I was in the process of building a professional services as part of a business that I was involved with. I was looking at building a lift and shift style operation, but as I think you were saying earlier on, like just lifting and shifting something from point A to point B, even if it's in the cloud, like this thing here, this is cloud, this is on AWS, right? It still costs a huge amount of money.
Yeah, I think that makes sense.
So for me, I would, if you're looking at migrating stuff into the cloud, then it's a totally different cost metric. What I have looked at a few times is, probably 10 of the projects that I've run over the last 10 years would be things where we've effectively replaced systems, but I've been careful not to describe those as replacements. Because if you describe it as a replacement, it just always fails. So we replaced some self-service stuff for Monash University, which is one of the largest change of address and that sort of stuff for students, built on some old technology, and we replaced that. We did actually turn it off. But the goal was to increase the number of self-serve customer transactions over and above where they currently were compared to the call center, because it was so useless that people would call into the call center. So we phrased it up as a business outcome rather than phrasing it up as a system replacement. And it paid for itself, I think, within 6 months. But again, it was a solution that was a lightweight solution around an existing system, and we didn't make the mistake. I think it's a really, really big mistake to ever replace something like for like, because you should take advantage of the fact that you're re-engineering something. You should take advantage of the fact that these days we probably look at the same problem and find a more efficient solution. You should delete pieces out of that process, which we did for the address change as an example. So I think in a lot of cases, if you've got solutions that have been engineered internally, you want to move them off platform, that quite often there will be a business case, but it is absolutely a different thing.
Question? Sir?
It's probably a follow-on from that question. So the sorts of challenges you see with the adoption of this sort of technology is very much based in what you touched on with the IT, the head of IT being the person who actually looks at whether this is fit for purpose or not. And then the next people that usually throw their hands in the air are the security folks, followed in short order sometimes by the compliance folks and the risk folks, because this thing lives over there somewhere and we don't control any of it really. How have you had to deal with that? And if you have, how did you kind of tackle some of that? Because that's something I've seen quite a lot.
Excuse me. So I've done it two ways successfully. I've failed a number of times. I think I've failed more than I've succeeded, but there have been some successes. So one way is to start with the business first and use the business to pressure the, I don't really like that approach personally. I'd rather stay friends with IT. But sometimes building something, so I remember a different solution that we built for Victorian government a few years later. The CIO at the time was quite resistive. We were working with the deputy secretary who had another type of problem in the briefing space. But it was, he said to me a couple of years later, he said, my problem was I was a victim of the system's success. He said, if I'd turned that off, I would have been lynched. So I think that's strategy number one for me, is develop some success. Pilots are a really good way of doing that, right? Because a pilot you can do for like 10% of the budget. You can still deploy it into production. So not a proof of concept, a real pilot. Just doesn't have single sign-on, may not integrate into everything. You know, you may double key some stuff while you're running the pilot so that no humans get hurt. So that's one way. You sort of use success as a subtle pressure. And this is strategy number two, probably isn't an alternative. It's probably an additive thing. Is you've got to go through those hoops, right? I'm going through those hoops at the moment. I'm in an APRA-regulated industry. I'm onboarding one of the cloud providers for platform as a service in data. And we've got to go through all the hoops, right? We've got to put all of the controls around it. We've got to draw the same architecture diagram that I've drawn 5 times before. Go through the same hoops. So you've got to do it. I think in particular, the vendor lock-in subtext that you had there is one of the common ones. And these days, it's so easy to just make sure, like what I say to people is, don't miss out on the $20 million a year saving just because you're afraid of something that might happen in the future that actually has never happened before. So this whole, I'm going to fall out of love with Microsoft and I want to get off the Microsoft platform entirely. And now I've got all this, all this stuff that's hooked in. So optimize for the big numbers and then have a backup plan for the small numbers. And it's not that hard, right? So most of the stuff now is Node. It's, there's not a huge amount of specific stuff. And we've had some experience porting off, what I would think of as probably one of the most proprietary app, because one of the, App Engine was one of the first really good platforms. We've had some experience porting off that and Data Store, right? So Data Store was really proprietary. It wasn't even like Mongo. It was this sort of weird, nasty, eventually consistent thing that was a pain in the ass. Sorry, a pain. Is this PG or? In the end, it cost 150. So this was a system that we built for 160 grand. Just a little lightweight system that hooked into back-end systems. A thin UI. It cost us 160ish from memory to build the system. We deployed it, ran it. It was generally under the free quota in dev and test and prod most months. Every now and again, it would get charged $2 for the consumption. Like it was that cheap. No humans to look after it because, of course, all the infrastructure is being looked after by Google. And then for strategic reasons, they decided they wanted to move that off onto AWS. We looked at it, and in the end, we did the code port for free because it was that easy. It cost $150 to run the project to establish the infrastructure, because in those days Lambdas weren't, Lambdas and S3 plus there was no, the serverless code framework, the serverless framework. That didn't exist at the time, so we couldn't really use Lambdas properly. They weren't really mature enough. So we were deploying onto infrastructure, right? So it cost them 150 grand, which is almost the same cost again, just to get that stuff. And we ported the code for free because it was that easy. If you're writing good code and you've got separation of concerns, it's not that hard to change a bit of code that's going to move it from Data Store into MongoDB or Dynamo, I think it was we used.
A lot of that comes from the traditional model of spending years building monoliths that are tightly coupled to some piece of infrastructure or proprietary software, and then thinking that you're going to do it all over again. And what I think people struggle with is the idea that you can do that $150,000 execution, do it in 9 weeks instead of 6 months, bank the 3 months you didn't spend building it, and then probably having a lighter weight operational model for it going forward. I think as an industry we haven't yet come up with a mature way of expressing that to the right people in big companies to make them comfortable in doing this, because and I think it's also culture change in some companies as well, which is it's a bit of a cliche, the fail fast or test and learn. And there are so many people who buy into that idea when it's all theoretical around the table when you're talking about
until something fails.
And as soon as it becomes all too real, they don't want to know anything about failure because it's it's damaging to their personal brand or whatever in the organization, but they haven't learnt that it's actually the right way to go about doing some of this stuff. So I think there's still some maturity to be gained, both as technologists and consultants and also as customers as well.
Yeah, look, I think you use a really good phrase that I've seen used really, really well. So not me, but my customer, Monash University, you know, they worked for, so it used the word bank. And I think that's, for me, it's banking, it's paying it forward and demonstrating the pace that you can move at is literally breathtaking for some people. So I remember we built the first system in the research department. I think it was thesis submissions. So it's a process around thesis submissions. You know, all of the data was in their big student administration platform, but it had a really clunky UI. No one used it. People rekeyed stuff like it was just old school. So we just built, again, then user experience around their student admin system. The head of research stood up in front of the whole of the IT team and just said, I've never seen anything like this. But then you've got this positive energy that has been banked. And when you do have a little bit of a failure down the track and something goes wrong, we had an issue with China at one point. You know, China and Google weren't getting on particularly well. And they've got a lot of students, some of the payment systems had to be reverted. It only took a couple of hours to sort it out, but it was a bit of a political pain. But that's exactly what it did. The CIO stood up in front of the head of research and said, you know, we've banked this much. this is the pain. And they accepted that. It's like, you know, we've got a huge amount of benefit from this approach. Interesting metric there, actually. I think they're our biggest customer. We ended up building around 35 systems. So you've got, what's the maths? Is that 105 environments? Dev, test, prod, 3 times 35? Anyway, I think it's 105. And of those, 80 were for free, including production systems, because they weren't hitting the quotas. Because these are systems that, like, you know, 3,000 people are using, and they're using them like for this bit of the day or for that bit of the day. So when you're running on platform and you're using this sort of consumption model, it's so cheap. And if you then subtract the humans, you'd normally have to look, like with 35 systems, you'd have to, you know, even in the model where you're paying, you've got a sunk cost in some existing infrastructure, you're still going to have to hire a few more people to look after another 35 environments, right? That's a lot of, like, at least 3, right? So that's a few $100,000 a year. And you just don't have that cost with these platforms because they're, you know, they're managed. If there's an outage, all you got to do is look at the outage and wait for them to fix it. So it's really compelling in ops as well, but the real savings aren't in ops. The real savings are in projects.
Awesome. Round of applause to Andrew Walker. Well, that's about it for tonight. I'm going to close off the live stream quite shortly, but yeah, hopefully we won't be strangers to the in-person meetup scene too much anymore. Yeah, it should all work out pretty well. But yeah, look, if you don't know my email, I've got a little consultancy myself, Cloud Shuttle. So just reach me at peter@cloudshuttle.com.au. If you're interested in doing a talk, just drop me an email. I'm not much of a hard taskmaster. You know, if you've got something interesting to say, you know, usually you can get a gig. So, you know, I think we just love hearing stories, you know, from people like Andrew Walker and the like, who just kind of, you know, living the dream and doing some serverless projects out in the wild. So anyway, thanks. We'll check you soon.